In this House of Logic video, we're going to do some more useful bits and pieces with Kubernetes with regards to actually getting data in and out of it. So if you followed previous videos in this series, you'll know that what we've actually set up is a Kubernetes master and a number of nodes within Proxmox. Now, the rest of these steps really don't depend that much on Proxmox. They're more specific to do with self-hosted. So if you've just got a self-hosted rig on another hypervisor, then you are welcome to follow along, and hopefully this will also be of use to you. So what we've actually got here is we've got the master and the 3 nodes, and I've already got this set up in Lens, and I've demonstrated what to do that previously. And this essentially is an empty cluster. There's basically nothing on it at this point in time. So there's no deployments, there's not, or other than the core DNS there, but there's basically nothing that is actually actively running on this. So what we're going to do is we're going to demonstrate how to go and set this up to do something a bit more useful. Now, what you want to do is, in order to get data out of this, you're going to want to have, certainly if you're self-hosting, some local storage for some degree of persistence. So first thing that you want to do is actually go on to each of your Kubernetes nodes, and you're going to want to set them up with NFS. And to do that, and I've already done this bit, so it's not going to actually do anything, you need to go and install the NFS common library. Now, that should, of course, just say, yeah, I've already got it, I don't need to do anything. Oh, it actually is doing it, so it's because I'm on the master. But I've done this already on each of the individual nodes, so it's already in place. So I'll just let that quickly run through. It won't take very long. Okay, so that's finished. And then what I want to do, so my NFS server, I've set that up separately. I'm actually using a NAS unit, and I want to mount that one up. So I'm going to use a mount command just to see if I can mount it. So it's set up with on volume 1 on K8s NFS, and just using the folder MNT, and that should hopefully work. Okay, so if I go to /MNT, which may say no, you can't do it. Okay, we're going to make ourselves super user, and we'll do that again. And within there, we've got some directories. We're going to go into example data. That's the one we're going to be using on this one. And if we have a look there, we've got an index.html. If we have a look at index.html, it's just got a straightforward HTML file, and it says some details about Saturday, May 17th, and that's it. Okay, right, so now we can actually come out of that. We'll go cd back to there, and then we'll do umount, because we don't want to be mounting that one up as part of the host. So that's removed. What you need to do to get Kubernetes to talk to it is you need to go and, first of all, you need to set up a storage class. Now, the storage class, the easiest way to do this, if you've got Lens, is actually you can make great use of the create resource option. So the storage class, first of all, if I find it, it's very straightforward. We'll just chuck that one in there, and then we can hit save. And immediately that's saying yes. And the storage class down here says, yep, you've got one. And then we need to create a persistent volume using the storage class. And I've already got this preset up, hopefully with the correct IP address. So it's another resource. You can't go and create multiple resources in a single file in Lens, it seems. I know you can get away with it using kubectl-apply. And you can also run these commands using kubectl-apply. But let's go and create that. So it's referencing the volume that we tried looking at previously. Okay, so that's gone through, and then we're going to go and create a persistent volume claim that our storage is going to use. So we'll create yet another resource and do the same thing. So now we have a persistent volume claim, as we can see there. Right, so with that in place, what we should be able to do is we should then be able to start creating an application. Now, the next step for this one is we are going to go and create an example app, and that consists, first of all, of yet another resource deployment. So we're going to go and do this. So that's going to create this example service, and it's using the shared NFS claim, which you can see there. So we'll hit save on that one, and then it should turn up under deployments. which it has just done so. So that's great. All very well and good, but the question now becomes, how do you actually do anything with that? So there's a service running there, and essentially you can't see it. So what you need to do is you can go and create a ClusterIP service, which will allow it to be visible within the cluster. So we will quickly do that now, and that's another resource. I'm going to include all of these, of course, in the in a repo on GitHub, which I'll reference in the description. So if we hit save on that one, and then go down to services under the network section, we should see we have a service. Okay, great. We do have a service, and it is on ClusterIP. So what we can now do, if I just refer to my notes quickly, is we can go and have a look at that service. But to do it, we need to go and create a debug pod. So let's go into terminal, and I'll clear the other stuff there so we don't get distracted by it. And we can go and do that. Worst thing about the terminal is you right click on it and it doesn't do anything. So this will create a debug pod. Well, certainly should do. Okay, and then we can try to curl to example service. Again, it doesn't like my. Let's just do it. Type it in, shall we? Curl http://example-service. Don't try and right click on this terminal menu, it just doesn't work. Have we got the right port number? Could not connect to server. It should be running. I may have missed something. I think I'll move on from this step because I know that some of the other ones are slightly more useful in my mind than this option. Let me give it one last go and see if that's any good. No, it still doesn't like it. Okay, let's exit out of that. Okay, so I'm not going to worry too much about that one. I'm probably doing something wrong. I may come back to that later on. But also what it should be possible to do is to create a NodePort based deployment. Now NodePort will give it an IP address and a port that it can bind to. More specifically, any IP address on your cluster should work. So if we paste that one in and we'll give that a go, we should see, there we go, example service NodePort. Great. Now, if I come out of there and I go into a browser window and we go and create a incognito, we should be able now, if we look at the correct port number on there, which I think is 30,080. So all being well, if we do http://192.168.5.231, that's just one of our nodes, 30,080, hopefully this should work, it says here, unless I've missed something drastic. Let's go back through and see what's missing. No, that's just about that. So let's see what pods we've got running. Let's have a look in. So we have the example service. It says that's running. Let's go back through our resources here and quickly check and see if I've missed something. So we have the storage, we have volume 1, KIS, NFS. That's the persistent volume claim. Let's close that down for a moment. So again, we've got the example service using the shared NFS claim. We had ClusterIP on port 80. And the node port there. Now, let's have a look back. Yep, there we go. So they're both saying that they're running. Let's go back to the browser and see if anything happened. No, it doesn't like it. It's taking too long to respond. I'm going to pause the video and see what I'm doing wrong. Okay, so I figured out what I've actually done wrong, and that was to deploy an older version of my deployment, which didn't actually have the container port listed. So there was actually nothing available to connect to. Now what I've actually done, so if I go back to the services here, you'll note that we have some actual port bindings turning up here, and in fact, if we go back to deployments. Sorry, not deployments, it's endpoints. So the endpoints turn up here. So these were actually blank. So what I've done is I've updated the deployment resource, as I said. So you can just do that by going in and actually you can either go in and edit the thing directly. So if you were to do something like this, you can actually get in and apply some settings. But in this case, I've done that. Now I've gone back into the actual debug container that I mentioned earlier, and you can see here that if we do curl to example service within the cluster, that's now successful. And externally, assuming this doesn't try and resolve to Google, which these things keep doing, so http:// then we actually do see the result successfully. So we're back on track now. And let me just remind myself of the next step here. So what you want to do, I mean, essentially, if you don't need to do anything externally to the cluster, and you're not worried about using IP addresses and ports, essentially you can kind of stop at this point if you wish. However, in a more of a production environment, what you're going to want to do usually is to set up a load balancer and to actually ingress using the address of the service. So example.yourdomain.lan is the one that we're going to be using on this. To set up the load balancer, you're in a slightly unique situation if you're running locally, which is typically when you're doing this in a cloud environment, the cloud will actually provision the load balancer for you and basically take care of things. But you can't do that if you're self-hosting, and you need to use another service such as MetalLB, which is what we're going to set up now. So if I just bring up another terminal session here, what we need to do is we also, oops, I've forgotten to do this, is create the MetalLB namespace. So that looks like this. So it's a very quick one, nice and easy. That'll turn up, then you'll see the namespace turn up on the list on the left, like so, and then you can go and create the config map as well. Now, the config map, we're going to come back to this one in a moment, but there's some custom resources, that the CRDs, custom resource definitions, that you're also going to need to create. Now, the easiest way to do that is to actually follow through what's the guidance on the MetalLB page. So we're first going to create the config map, and that's got an IP address of 5.234 up to 5.239. So those addresses and the layer 2 option are the ones that we're going to be using within our home lab setup, basically. So I can hit save on that, and then we should see that turn up underneath config maps. We'll filter that down to the MetalLB system, and yeah, there we go, we've got those in place. Okay, so back to the terminal window, and what we need to do is we need to apply the MetalLB config, and that's easiest done this way using kubectl apply. So that's telling us it's setting up all of the different roles and so on and so forth. And different components, and you can see those if we go back to, let's go to pods at this point, and we'll see those are currently in pending state. So we're going to give that a moment, and those should start to come up. But what they won't do is they won't actually do anything until we run the next step. So there we go, we're starting to be running now. So yeah, the problem that you will have with MetalLB, if you've just followed these steps, and it's a little bit tucked away, I think, on the MetalLB website, is that there is actually a migration procedure to go from the config to the CRD's custom resource definitions. So what you've got here is the procedure, so it's very straightforward. So that's your example config file, so that's fairly typical of what we've got, although that's got some BGP stuff in it, and it actually will then produce some custom resources off the back of that. we need to run this directly on the master, but we can't do it via lens. So if I go back to my PowerShell window, we are going to copy the information here. I've also linked to this in the repo, and we paste that one in there, and that's going to go and pull down the Docker container, do its thing, create a config map file from the config in Kubernetes, and then spit it out as a resources .yaml file, which if we now do an ls in the directory, we've got a resources.yaml, and we can then do a very simple command, which will be kube control apply -f resources. And immediately that's said, it's created the address pool and the layer 2 advertisement, which is what we need in order for it to work properly. So going back over to Lens at this point, if you really want to, you can find the custom resources down here, and you can see we've got various bits and pieces here, like the IP address pool. All good. So what we would now need to do is actually get set up with an Ingress. And to do the Ingress, you need yet another bit of third-party software, which is you're going to use an Nginx Ingress using Helm. And to do that, we are going to again run a command. I'm going to do this because it's not a kube control command. I'll do this in PowerShell again, so directly on the master node. So we're going to add, there we go, add Ingress Nginx already exists. But if you needed to add the repo, that's how you would do it. And then you do an installation of the Nginx Ingress controller. And that may take a moment or two, but I would expect to start seeing that turn up within deployments and within services. Okay, so that has been successful. It's actually giving you an additional command here, which is useful, and I've included in the documentation, which you want to run this, which will get you the Nginx Ingress controller IP address. And so it has picked up the first of our IP addresses from our range that we fed into MetalLB, which is 192.168.5.234. Great. Now, what you would also need to do for your application is you need to create it or give it a definition with an ingress on it. So, third and final type of ingress for this service, or rather service type, is using an ingress, is to put this one in. So we're going to use example.yourdomain.lan. It's going to be basically an ingress type. We've got the ingress set up with Nginx. All we need to do is hit save. And we can now go over to ingresses, and then that should show within there, I would hope. Or certainly if not there, within services. There we are. No, we're still, I see what I'm doing wrong. I hadn't included the default namespace. There we are. So we have our example service, we have our ingress controller, we have our IP address, as we saw on command line. If we go to ingresses, there is our service, and it has got the rule defined of example.yourdomain.lan goes to example service on HTTP. So what we can then do, and this is final couple of steps, is you would need to either go and set this up on DNS within your local environment, or you need to go and edit the host file. Now there's a very handy host file editor here that comes with Windows Power Tools, which I'm going to use. So we're going to update the IP address there. We're going to set that to active, and we're going to hit update. So I don't need to go and make any DNS changes because I'm just going to access it from this laptop. But if you want to do anything external or anything for anything else, you're going to need to go and set that up on DNS. So if we do http://example.yourdomain.lan, well, we hit the Nginx, but why haven't we hit the rest of it? That is the question. We have certainly got most of the way there. What's wrong? I will quickly pause the video and see if I can figure that out. Okay, so it's taken me a little bit of time to dig into this, and I've done various things like actually deleting pods and things in order to force through restarts. Ultimately, what I found out that seems to be related to one of the annotations on the example service ingress. So what I've done is I've gone and split them out into individual actual services now. So we have a service ingress for the ingress, we have an internal one for ClusterIP, so ClusterIP also applies for the ingress, and we've got NodePort as well still in existence. So what that now means is that if I open up this browser, then you can see we have the same details there as we have there. So just refreshing that, you can see it's coming from both. And if I go over to command line and I do wget, as you can see, various failed attempts, and do wget to example.yourdomain.lan, and then it is coming back with the same body content there as well. So all that it was actually one of the path rewrites, which you can see, which I've basically deleted and changed to a simple annotation type on that particular ingress, and that's it. So there we go. That is slightly more troubleshooting involved than I was expecting. That is how to add an ingress and NFS backed storage with MetalLB as a load balancer on Kubernetes, and you can do that on Proxmox or otherwise. So thanks very much for watching. I hope this has been of use, and if you like it, please like the video and subscribe to the channel. Otherwise, we'll catch you next time. Thanks very much. Bye now.